Hi, I'm Sangitoji from BE4M. Today, me and my friends Kingawachu, Pupa, and Kamaishi will be presenting about the configuration of industrial robot.
Outlines.
Here is the basic outline of our presentation. Firstly, I will briefly introduce what industrial robots are and then discuss various configurations of robots such as polar, cylindrical, Cartesian, articulated, and scalar.
Introduction.
What are industrial robots? And industrial robots are electromechanical programmable devices that are designed to perform a variety of tasks in manufacturing and industrial settings. The first industrial robot was introduced in 1960s as per various sources. Since then, industrial robots have evolved significantly with modern versions including collaborative robots that are commonly termed as cobots as they can work alongside humans and autonomous mobile robots that can navigate and perform various tasks independently. They typically consist of robotic arm, sensors, actuators, and a control unit. These robots can handle various tasks such as repetitive, dangerous, or tasks that require high precision such as assembly, welding, painting, and material handling.
Common robotic dot configuration.
There are five basic configurations of industrial robots as per various sources. These are based on the coordinate system of motion of the manipulator and end effector. These configurations include polar, cylindrical, Cartesian, jointed arm, and scalar. Jointed arm is also referred to as articulated robots. Each of them will be discussed in detail in the next slides.
Polar dot configuration.
So to continue with the presentation, I would like to talk about the polar configuration. So first of all, talking about its structure, the rotating base. The base of the robot can rotate around a central axis. This rotation allows the robot to cover a circular area around its base, providing a wide range of motion. And regarding the sliding shoulder, the shoulder connects the rotating base to the arm of robot. It typically allows for up and down movement similar to that of a human shoulder works. Next, about the sliding arm. The arm can extend and retract much like a telescopic mechanism. The sliding motion allows the robot to reach further distance from its base. So the combination of rotating base, shoulder, and movement sliding arm provides the robot with a versatile range of motion, making it capable of performing complex tasks. So next to talk about the motion. So it's about the spherical motion. The combination of rotating base, shoulder, and sliding arms shows the robot to move in a spherical manner. This means it can cover a wide range of angles and distances similar to the surface of a sphere. This type of motion is beneficial for tasks that require precision and flexibility, as the robot can easily adjust its position and orientation to reach different positions in its workspace. Now, the applications. It is widely used for applications such as welding, casting, etc.
Cylindrical dot configuration.
So now next, the cylindrical configuration. So firstly of all, I would like to talk about the structure. So first, similar to that of the polar configuration, the rotating base. The bottom part of the robot can turn around its central axis, providing rotational movement. Secondly, the vertical column, as we can see in the figure, a tall upright structure that supports the arm and allows it to move up and down. Similarly, the sliding arm as that of the polar configuration, the arm can slide vertically along the column and extend outwards, providing a combination of vertical and horizontal movement for the cylindrical configuration. And next to talk about the motion. So first, the two linear joints. One linear joint allows the arm to move vertically up and down along a column, and the other allows the arm to extend and drag horizontally. Next one rotation. The base of robot can rotate, allowing the entire structure to turn around a central axis or a point. Next, the application. So cylindrical configuration has a wide applications such as that of assembly operations. The robot can be used to assemble parts in manufacturing process where precision and repeatability are crucial. Next, handling machine tools. Tools, it can load and unload materials from machine tools such as CNC machines, enhancing automation and efficiency. And next, about the spot welding. The robot can perform spot welding tasks, join metal parts at specific points with high precision.
Cartesian. Coordinate.
I will basically talk on the Cartesian coordinate and articulate coordinate. I will explain this topic on the basis of structure, motion, and application. And here I will begin with Cartesian coordinate. First one is structure. In terms of structure, it is also divided into three parts: three linear axes, rigid frame, and effector. I will begin with three linear axes. The robot is built with three linear actuators, each corresponding to the one of the Cartesian axis. Second one, it is end effector. Second one, it is rigid frame. The structure is typically a rigid frame that supports the linear actuator and ensures stability and precision. And third one, it is an end effector. The tools or device at the end of the robot arm that interacts with the workpiece, such as gripper, welding torch, or 3D printer nozzle. And second one, it is on the basis of motion. Even in terms of motion, it is divided into two parts: straight line motion and three linear joint. I'll directly explain on the basis of straight line motion. The robot moves in straight line along three perpendicular axes, x, y, and z axis. This is similar to how a point moves in a Cartesian coordinate system. Second one, it is a three linear joint. Each axis has a linear joint that allows movement in one direction, providing precise control over the position of the end effector. And third one, I will explain on the basis of application. The application of the Cartesian coordinate are CNC machine, 3D printing, and pick and place operation. I will explain individually. In terms of CNC machine, the Cartesian robots are used in CNC machine for tasks like milling, drilling, cutting, where precise movement along the x, y, and z direction axis is essential. And in terms of 3D printing, the Cartesian robot controls the movement of the printer head to accurately deposit material layer by layer. And third one, it is pick and place operation. In terms of pick and place operation, Cartesian robot controls the movement of the printer head to accurately deposit the material layer by layer.
Articulated dot configuration.
Here it goes with articulated. It also consists of structure and motion. And under structure, it is subdivided into four parts: base, shoulder joint, wrist, and elbow. And I'll directly explain. Start with the base. It is similar to the configuration of human arm and consists of following parts: the human arm-like design. The robot has a structure that mimics human arm, with joint that acts like a shoulder, elbow, and wrist. Shoulder joint allows the arm to rotate and lift. Elbow joint provide a bending motion, enabling the arm to reach different positions. Wrist joint offer a precise control over the end effector orientation and movement. And in terms of motion, it consists of the multiple rotary joint. Under motion, the joint coordinate system, the robot moves using the multiple rotary joints, similar to how human moves their arms. This joint allows the robot to rotate and bend at various points, providing a wide range of motion. And in terms of application, It is used in material handling and painting.
SCARA,
I'm going to talk about the SCARA. SCARA stands for Selective Compliance Assembly Robotic Arm, and it is used for pick-and-place or assembly operations where high speed and high accuracy is required. Now let me talk about the structure of SCARA. Under the structure, there is three types. First one is two parallel rotary joints, and this joint allows for horizontal movement in XY plane. And second one is rigid Z-axis. The Z-axis is rigid and it provides stability for vertical movement. And third one is an effector. It is the tool or the device at the end of the robotic arm, and it is used to interact with the environment. Now I'm going to talk about the motion of SCARA. There is two types of motion. The first one is horizontal motion. SCARA robot excel in precise horizontal movement, so it can move precisely in horizontal directions. And the second one is a three-axis motion. Two rotary joints for the XY movement and one linear joint for the Z-axis movement. Finally, I'm going to talk about the applications of SCARA. It is used for assembly operations, and it is also used for pick and place tasks, and it can be used in machine loading and unloading.
Conclusion.
To conclude our presentation, industrial robots are electromechanical devices that are used in manufacturing industries. They can either work independently or under control of human operator. Based on how they move, it consists of various configurations such as polar, Cartesian, cylindrical, and articulated, or SCARA. Thank you one and all for listening.